Alright, I know this is going to sound really strange, but I absolutely love this next topic here. And I'm going to give you a quadratic. I'm going to say x squared plus 2x minus 15 is less than 0. And now it's a basic quadratic equation, but it's not an equation at all. It's an inequality. So what I'm going to do is I'm going to factor this, and I'm going to set it equal to 0. And some people might say, well, that's a silly thing to do, but that's what I'm doing. So if you don't like it, that's perfectly fine. I'm just using it because I want to find out that if it was equal to 0, I would have these two values, x equals -5 or x equals 3. And that's just from basic factoring and saying that equals 0. Now here's the part I like. I'm going to solve this using a chart. So what I do is this. I make a chart. Oh, goodness me. I tried to use straight vertical and horizontal lines. Sometimes that happens, sometimes it doesn't. I plug in these values, a -5 and a +3. And I put in another line here. And then what I'm going to do is I'm going to take a look at one last thing. And the last thing I notice is this. At one point in time, I had x plus 5 times x minus 3 equals 0. But what I really had, I just did that for computation's sake. What I really had was this. X plus 5 times x minus 3 is less than 0. Now here's the part I like about this. If x plus 5 was a and x minus 3 was b, if a is positive and b is negative, then it's less than 0. The product would be less than 0. And similarly, if a was negative and b was positive, their product would be less than 0 because it would be a negative number. So what I'm going to do is I'm going to put in x minus 3, x plus 5. Now I'm going to draw this line. And now I know what happens. I know what happens when x equals -5. This whole thing turns to 0, and that's going to be no good. So what I'm going to do is I'm going to switch color shades here. Now I'm going to pick a number less than -5, and let's say I pick -10. All right. So -10 and a -3 gives me a -13, which is negative. Look at that big negative sign. If I picked here, I'd have a -10 and a -5, which is -15. Or I'm sorry, I have a -10 plus 5, which is still a negative. A negative times a negative is a positive. So that's going to be positive. Here, I'm going to pick a number between -5 and 3. Well, between -5 and 3 is the easiest number to work with, and that's 0. So I say 0 minus 3 is -3, so that's negative. 0 plus 5 is 5, which is positive. So if I had 0 in for here, I'd get positive 5 minus times a -3 is a -15, so I get a negative value. And then here I just pick any number greater than 3. How about 5? Right? It doesn't matter. You can pick any number, but it just has to be greater than 3. That's what these are like fence posts. So in between, and then on the sides. So if I pick 5, I get 5 plus 5, which is 10, which is positive. I'd get 5 minus 3, which is 2, which is also positive, and I'd get a positive. So now, using that information, I take a look and I say, well, I want it to be less than 0. I want my quadratic to be less than 0, which only happens between -5 and 3. And here's the other thing that's important to notice. It's less than. So it's going to be open brackets. Not open brackets. It's going to be open parentheses. If you want to show this, you can. Oh. And Benji's trying to show you a card that he has, which is 6 minus 3, which equals how much? Think about it and then come back and tell us. All right. I'm going to give you one more example. Give you one more example real quick.
Dad, can you tell them what it is?
Well, you tell me. What's 6 minus 3?
6, 1, 2, 3, 4.
And while Benji's thinking about that, I'm going to give you another example. And this one's going to be x squared
7, 8, 9. Is this 1
plus 2x
2, 3, 4, 5
plus 1.
7, 8, 9, 10. 10!
No, 6 minus 3 is not 10. So I'm going to factor this one, and this one becomes a little
Dad,
bit weird
can you
because
please-
it's x plus 1 times x plus 1, which is greater than or equal to 0. So I need x to equal a negative 1, so my chart is going to be a little bizarre this time. And
Dad, can you tell them what this is?
6 minus 3 is 3. So if I
6
use a
minus
negative 2, I get a
3
negative
is
and a negative.
6
The
minus
positive.
3 is 3.
If I use a positive, I use a negative 2. If I use a positive, oh, once again, I'll stick with what I said before. I'd use a 0. I get a positive and a positive, which is also positive.
2.
But oddly enough, it's going to be all real numbers. It's going to be from negative infinity to negative 1, but the ones included
1, 2, 3,
or negative 1 to 0, but that's, oh, I'm sorry, but that's just silly anyway because we wouldn't say that. We would say
2,
negative infinity to positive infinity.
3, 4, 5.
Probably wasn't the greatest example to use, so I'll give you one last example. That one was kind of a silly one to use. And let me just make my eraser much bigger. And so I'm going to give you one last example. I'm going to say x squared, let's say
2, 3,
uh,
5, 6, 1.
plus 2x minus 8 is greater than or equal to 0. You factor this.
2
You can
and 4 is 6.
2 and 4 is 6. That is correct. It's greater than or equals to 0. So now I'm going to say x equals negative 4 or x equals 2. Those are my fence posts, negative 4 and 2. And then I put in these, x plus 4 and x minus 2.
1 is 1. 1 take away 1 is 1.
That's not true. And so if I plug in a negative 5,
Dad, is this take away?
that's going to be negative, and that's going to be negative, and that will be a positive. If I put in 0, I get a positive and a negative, which is negative. And if I put in a 5, I get a positive and a positive, which is also positive. But now I need it to be greater than or equal to, which means, because that's greater than or equal to 0, means my answers must be positive. My products must be positive.
Let me try again.
All right, what do you think?
1 and 1 is 2.
1 plus 1 is 2. Good.
I
So it's
looked
going to
at
be,
the card.
oh, good. Negative infinity to negative 5 inclusive, or positive, oh, shoot, that's not a, sorry, I'm slightly distracted by, that should have been a negative 4. Slightly distracted by my assistant,
1, 2,
because these are the values.
4, 5,
And that's it.
6, 7, 8.
So that's it with graphing quadratics. I hope you liked it.